All right, so what I want to do is start with a square to come up with how this is going to work. So there's my square. And I'm going to start by saying each side is 1. And I'm going to draw in the diagonal. All right. First off, what is, in a square, what is this angle? Right angle. What does the diagonal do to these angles? Cuts them in half, so each of these is 45 degrees. So this is a 45, 45, 90 triangle. A 45, 45, 90 triangle is half of a square. We're cutting the square in half. So let's call, so the diagonal, is that A, B, or C in my right triangle? Is that the hypotenuse or A or B? That's a C, that's a hypotenuse. So I'm going to call this H for the hypotenuse. Let's find the length of this hypotenuse if the side length of the square is 1. We're going to use the Pythagorean Theorem. So I get H squared equals 1 squared plus 1 squared. So H squared equals 2. Take the square root, and H equals the square root of 2. So that would be simple radical form for the hypotenuse. Now let's make the side length of our square each side 2. And use the Pythagorean theorem. H squared equals 2 squared plus 2 squared. So H squared equals 2 squared, and 2 squared is 1 is 4, so H squared equals 8. So H equals the square root of 8. I can simplify that. That is 4 times 2. So H equals, square root of 4 is 2, so I get 2. And the square root, this 2 has to stay inside, 2 square root 2. Let's do side length 3. So H squared, 3 squared plus 3 squared. So H squared equals, this is 9 and 9, we get 18. H equals the square root of 18. And we can simplify this, write it in simple radical form. Square root of 9 is 3. 3 square root 2. Do we see a pattern here? 1 square root 2, 2 square root 2, 3 square root 2. So let's do this for x, just some side length x. So H squared equals x squared plus x squared. We did something like this. There was a problem like this in our homework. So H squared, how many x squareds do I have? 2. 2x squared. Take the square roots to undo the square here. What's the square root of x squared? X. So the x comes out front. Square root of 2. So no matter what the side length is, the hypotenuse is the side length times the square root of 2. So what we've just done is proved the 45, 45, 90 theorem. The 45, 45, 90 theorem tells us that in any 45, 45, 90 triangle, the hypotenuse is square root of 2 times the length of the leg. And we draw a quick picture here just as a reminder what we mean by the leg. So there's, so for a 45, 45, 90 triangle, that side is the hypotenuse. across from the right angle. And because these are each 45 degrees, the legs are both the same. Makes this and it's half a square, so the legs are both the same. We're cutting a square in half, so each of the legs is the same. So this works for any 45, 45, 90 triangle. As long as we have those angles in there, this is going to work for us. So what I want to do is we'll draw a picture. We'll get a nice visual of how this works, so we can remember how this works to solve problem. What this lets us do is shortcut the Pythagorean theorem. We don't have to use the Pythagorean theorem every time on a 45, 45, 90 triangle because it's half a square. And it's always going to work out this way. But I wanted to talk a little bit about the Pythagoreans and the square root of 2. So in Greece, the Pythagorean theorem, named after Pythagoras, he came up with a proof for the Pythagorean theorem. People, like I said yesterday, people knew about the Pythagorean theorem for a long, long, long time. It's been around for a long time. The Pythagoreans in Greece, it was kind of like a religion, kind of like almost like a cult. They had special diet. They met in secret places. They had secret codes and secret handshakes, that kind of thing. And part of what they believed was that everything in the world could be written as fractions of whole numbers. So no matter what it was, you could describe it with fractions of whole numbers. Well, a person by the name of Hypasus, or Hypatius, sometimes you'll hear it pronounced, was working on this idea of the diagonal of a square with side length 1. And Hypasus figured out that the square root of 2 was not a fraction of 2 integers, or 2 whole numbers. That it was what we call now an irrational number. We can't write it as a fraction of 2 whole numbers. Well, to the Pythagoreans, this is like finding out that there's no such thing as Santa Claus, and there's no Easter Bunny, and there's no Tooth Fairy, all at the same time. It was one of their major ideas in their religion was this idea of the ratios of whole numbers. Well, Hypasus wanted to tell the rest of the world that the diagonal of a square was not a rational number. That was a big deal. And the Pythagoreans wanted to keep it secret. They wanted everybody still to work with this idea of ratios of whole numbers. So the legend has it that the Pythagoreans killed Hypasus for wanting to spread that idea to the rest of the world. So mathematics can be a pretty high stakes game, even when it comes to something as easy as the length of this diagonal of a square. So, interesting story that has to do with the Pythagorean theorem and square root of 2. All right, so let's draw a picture of how we're going to use this 45, 45, 90 theorem. Gives us a nice way to remember how this works. If we want to open that. So here's our 45, 45, 90 triangle. Here's our 45, 45, 90 triangle. And we're going to label, I'm going to call this side the hypotenuse, and I'm just going to use P, and this is a leg, and this is a leg. The legs are always the same because they're the sides of the square, so they're the same. If we want to go from the leg to the hypotenuse, so we know the leg, we want to figure out the hypotenuse. Multiply by the square root of 2. That's all we have to do. So if we know the leg, we want to figure out the hypotenuse, multiply by the square root of 2. If we have the hypotenuse and we want to figure out the leg, so here's our hypotenuse, there's my 45 degree and my 90 degree angle. To go from the hypotenuse, if we know the hypotenuse and we want to figure out the leg, what's the opposite of multiplication? Division. We're going to divide by the square root of 2. That's all we have to do. We don't have to worry about the Pythagorean Theorem. Don't have to simplify it. We'll end up having to simplify some radicals, but it'll be a little easier, I think. And those are the only two rules we have to remember for 45, 45, 90. We're either multiplying by the square root of 2, dividing by the square root of 2. That's all this is. For this particular, we'll talk about one other kind of special right triangle. But that's the whole point of special right triangles, is we can shortcut the Pythagorean theorem. A couple of things to remember about this. We have to make sure before we start multiplying and dividing by the square root of 2, we have to make sure we have a 45, 45, 90 triangle. We can't just do it on any triangle. It has to be a 45, 45, 90. And I'll talk about some other things we have to be careful of as we do a couple of examples. So let's look at a couple of examples. So here's our triangle. All right, so what I suggest you do to help you out is let's label the sides. So is x the hypotenuse or the leg? Hypotenuse. It's across from the 90 degree angle, so it's the hypotenuse. So that's going to be the leg. To go from the leg to the hypotenuse, what do? Multiply by the square root of 2. So x equals 5 square root of 2. We're done. That's all we have to do. Don't have to do the Pythagorean theorem. I just multiply the leg by the square root of 2. There's my answer. Let's look at another example. So here's one where we have a little more work to do, but it's still pretty easy. Let's say this is 8 and this is x. All right, so x, the leg or hypotenuse? X is the leg, so 8 is the hypotenuse. To go from the leg to the hypotenuse, divide by square root of 2. So I'm going to do, whoops, I drew my arrow the wrong way. I'm going from the hypotenuse to the leg. So we still divide by the square root of 2. But I drew my arrow the wrong way. Divide by the square root of 2. So x equals 8 divided by the square root of 2. Do we remember what we have to do if we have a square root in the denominator? We usually don't like to write our answers with square roots in the denominator, so we do what we call rationalize the denominator. And to rationalize my denominator, all I have to do is multiply the top and the bottom by the square root, whatever the square root is in the bottom. So I'm going to multiply by the square root of 2 over the square root of 2. This is just 1, so it doesn't change my answer. And I can't multiply numbers that are one outside, one inside, so I leave that written as 8 square root 2. And the square root of 2 times the square root of 2 is, since they're both under the square root, I can multiply them together. So I get the square root of 4. 8 square root of 2, what's the square root of 4? 2. These two numbers are both outside the square root, so I can divide them. So I get 4 square root 2. And that would be my answer. And anytime we multiply a square root of a number by the square root of a number, we just get the number back out. The square root of 2 times the square root of 2 is just 2. So this would be my answer here, 4 square root 2 units. Questions on that example? All right, so another mistake that students make, or an idea that they think about 45/45/90s, is that our answer will always have a square root of 2 in it. It'll always have something to do with the square root of 2. Not necessarily the case. So let's look at an example of that. So here's my triangle for this one. And we want to find x here. So let's label our sides. Is x the hypotenuse or the leg? X is the hypotenuse. This is going to be our leg. So we want to go from the leg to the hypotenuse. How do we go from the leg to the hypotenuse? Times square root of 2. We multiply by the square root of 2. So I get x equals, Marcus says 3 square root 3 times the square root of 2. The numbers under the square root, if they're both under the square root, I can multiply them together. So I get x equals 3 square root 6. And that's my answer. I can't simplify square root 6. But square root of 2 isn't in my answer. So just because it's a 45/45/90 triangle doesn't mean I have to have square root 2 somewhere in my answer. So questions there? All right, let me see if I can trick you guys. All right, we want to find x here. Sam says 7. Why is it 7? They're both legs, right? This is a leg, and this is a leg. So x equals 7. So make sure you're using the right sides. A lot of times students, when we talk about 45/45/90 triangles, they want to multiply or divide everything by the square root of 2. So these two are legs, so they're both the same. So our legs are always the same. All right. Let me look at one last example, and then we're done. So here's my triangle for this one. This is 5 square root 7 x, and this is a 45-degree angle. So 5 square root 7, hypotenuse or leg? That's our hypotenuse, opposite the 90-degree angle. And this is going to be a leg. So to go from the hypotenuse to the leg, what do? Divide by the square root of 2. So x equals 5 square root 7 divided by the square root of 2. I need to rationalize the denominator. So I'm going to multiply by the square root of 2 over the square root of 2. I get 5. The numbers under the square root I can multiply. 5 square root 14. And the square root of 2 times the square root of 2 is square root of 4, which is 2. That would be my answer in simple radical form. 5 square root 14 divided by 2. If I needed an approximate answer, I could plug all this into my calculator and calculate. So we don't always get a square root of 2 in our answer. So whenever we're working with 45, 45, 90 triangles, we're using those two rules. To go from the hypotenuse to the leg, divide by the square root of 2. Go from the leg to the hypotenuse, multiply by the square root of 2. The legs are always the same. That's all we have to remember about 45, 45, 90 triangles. Questions? Okay. Let me write up your homework. Short assignment for the weekend. There we go.